So this is the second part of our review session for the final exam. So let's get down to the business. Find the solution set of the inequality 2 times 3x minus 1 minus 5x less than or equal to 2 plus 3 times 1 minus x. So this is just a linear inequality. So all we need to do is to isolate the variable x on one side of the inequality and the constants on the other side of the inequality. So let us first expand. Let us multiply what we need to multiply first on each side of the inequality. So in here, we will have 6x minus 2, then minus 5x. This will still be less than or equal to 2 plus 3 minus 3x. And now we put all the terms with the variable x on the left-hand side, okay, by using transposition. So we put this on this side. And then we put the constants on the right-hand side. So this guy here, we bring it to the other side in here. And then we just simplify, okay? So this means that we will have 6x minus 5x plus 3x. This will still be less than or equal to 2 plus 3 plus 2. So if we simplify this, we will get 4x on the left-hand side of the inequality, still have less than or equal. And then on the right-hand side, we will have 7. Okay? And then if we divide by 4, take note that we are going to divide by a positive number. The inequality here won't change. So this will be x less than or equal to 7 over 4. So this is the solution set of the inequality. Well, this is the condition for x to satisfy the inequality. For the solution set, let me just write it here. So solution set, you can use the interval notation. So this will be from negative infinity up to 7/4, and then you close this with square brackets. And this is the solution set. Okay? Next problem. Solve the system using a method of your choice. So for this, we have 2x minus 3y equals 7. And then 5x plus 7y equals 12. So what we're going to do here is to use elimination method. So we will use elimination method. Elimination method. So if we label this as our first equation, this is our second equation, then let's try to eliminate x first. Okay, so eliminate x. So for this, we multiply equation 1 by 5. So 5 times equation 1. And then we multiply equation 2 by 2. So 2 times equation 2. So 5 times this first equation, we will have 10x minus 15y. This is equal to 35. Okay? So we multiply each term here by 5. And then for the second equation, we multiply by 2. So we will have 10x plus 14y. this is equal to 24. Okay? And from here, we can subtract. Okay? We can subtract the 2, which means that we will have 10x minus 10x, that's just 0. Here we have minus 15y minus 14y. That will become minus 29y. Then equals. Here we have 35 minus 24. That's equal to 11. And from here, we find that y equals 11 over, or negative 11 over 29. Okay? And then for the variable x, let us eliminate y. Eliminate y. So for this part, what we're going to do is to multiply the first equation by 7. And then the second equation, we multiply it by 3. So for the first equation, it becomes 14x minus 21y. This is equal to 49. And then for the second equation, we will have 15x plus 21y, okay, equals 36. And then we can add the two guys here. So we will be able to eliminate this guy here and this guy here. So adding, we will have 29x. This is equal to 85. Okay? And therefore, we will have here x equals 85 over 29. So this is the value for the x. Okay? Questions so far? Okay. Now let's do the following. Give the equation in standard form. So take note of this, in standard form of the line passing through the point negative 2, 6 and parallel to the line 2x plus 3y equals 4. Okay? 2x plus 3y equals 4. So solution. Remember, if a line is parallel to another line, it means that they have the same slopes. Okay? So what you can do is to calculate the slope here. Okay? The slope of the given line. Okay? Then you can write the desired line on the form or in the form y equals mx plus b, where m here, it's the slope of this guy here. Okay? And your b, you will be able to calculate it when you substitute x and y using the point negative 2, 6. That's one way to solve this. Another way to solve this is that if two lines are parallel, then they will have the same coefficients for x and y. Okay? So in here, the desired line has equation of the form, okay? We have 2x plus 3y equals c. And here, we need to identify what this C is. Okay? If the desired line passes through this point, then all we need to do now to calculate the value of C here is to substitute this point to the variables. Okay? So to find C, we use the point -2, 6. So this means your C, this is equal to 2 times x, which is -2, plus 3 times y, which is equal to 6. So this will be equal to -4 plus 3 times 6, that's 18. So this is equal to 14. So we now have a value for C. Therefore, the line has equation. So let's write here. Therefore, the line has equation. We have 2x plus 3y equals C, which is equal to 14. So this is the line parallel to this line here and contains this point. Okay? Questions? So again, we wanted to write the line in standard form, and this is the standard form. Okay? Next problem here. Find the slope of the line with equation 2x plus 3y plus 2 equals 0. Then sketch its graph. So in here, we need the slope. So from this form, we write it into the slope intercept form. Okay? Slope intercept form. So you have 2x plus 3y plus 2 equals 0. This will be equal, this can be written as 3y equals minus 2x minus 2. And your y, this is equal to -2 over 3 x minus 2 over 3. Okay? So what does this mean? Slope is -2 over 3. That's just the coefficient of your variable x in here. Okay? Next, we want to sketch the line. Okay? So you see here, this is the y-intercept, which means that if x equals 0, the value of y equals -2/3. So let us just label our grid here. So say this is -1 here, 1 to -2 here, then here 1 to +1 here, +2 here. This is +1 for y, +2 for y, etc. Let's add more here, -1 for y, -2 for y. So we can take the first point in here, this guy here, when x equals 0, okay? So when x equals 0, y equals -2 over 3. So that point will be this point. Let us label this. This is -2, this is 0, comma -2 over 3. Okay? And then we can now find another point, or we can use the slope if you want. Okay? But in here, I'll just find another point. I'll let y equals 0. So when y equals 0, we'll have 2x plus 2. This is equal to 0, which means we have 2x equals negative 2, or our x equals negative 1. So the other point will be here. So this is the point negative 1, comma 0. And therefore, we can now sketch the line. Okay? The line will be something like this. Okay? So pretend that it's a straight line, but yeah, this is the line. So this is the sketch of 2x plus 3y plus 2 equals 0. Okay? Questions? Next problem here. Find the vertex and the intercepts of the parabola y equals x squared plus 4x plus 3. Then sketch its graph. Okay? So to solve this, we can let this guy here to be our f of x. Okay? And for the vertex, you have h comma k. Okay? With h, this is equal to negative b over 2a. Correct? Negative b over 2a. And in here, this is of the form ax squared plus bx plus c. So a, it's 1, b equals 4, c equals 3. So we'll be able to find h to be negative 4 all over 2 times 1. 2 times 1, it's just 2. So this is equal to negative 2. Okay? And then for for k, this is equal to f of h, or this is equal to f of negative 2, which means we'll just have negative 2 squared plus 4 times negative 2 plus 3. This is equal to 4 minus 8 plus 3. And then this is just equal to negative 1. Okay? So the vertex is h comma k, and that's just negative 2 comma negative 1. Okay? And then on this graph, let us try to, on this grid here, let us try to sketch this vertex. Okay? So for this grid, I label every 2 ticks, that will be 1 unit. So this is negative 1, negative 2, negative 3. This is positive 1 for x, positive 2, positive 3. This is positive 1 for y, positive 2, positive 3. This guy here, it's negative 1 for x, negative 2, negative 3. So we want the vertex which is negative 2 comma negative 1. So x equals negative 2, y equals negative 1. So this is where the vertex is. So in here, the coefficient of x, it's just 1. It's positive. So the graph of the parabola will be opening upwards. So let me put the label of the vertex at this part. So it is at negative 2 comma negative 1. Okay? Now, for the intercepts, let's start with Y-intercept. So for Y-intercept, we let x equal 0. So y, this is just equal to 3. Okay? So Y-intercept is 3. So this means Y-intercept equals 3. And the point 0, 3, that will be on the graph. So it's this guy here. So this is 0, 3. And then let's find X-intercept. So X-intercept, for this we need y equals 0. So we will have x squared plus 4x plus 3. This is equal to 0. You can solve for this quadratic formula or quadratic equation using your quadratic formula, or you can use your factoring. I'll use factoring in here. We can easily factor this into x plus 3 times x plus 1. So that's equal to 0, which means that we will have here x equals negative 3 or x equals negative 1. So this means that x-intercepts are negative 3 and negative 1. So on the grid, we have the points negative 3, 0. So the x-intercepts, these are negative 3 and negative 1. So for the intercept negative 3, we have the point negative 3, 0, which is in here. And then for the intercept negative 1, we have the point negative 1, 0, which is in here. So now we can sketch the graph. That's all we need. It says find the vertex and then the intercepts, and we found them. And then we sketch the graph. So the graph will be something like this. So take note that this is a parabola. So try to make sure that at least you give justice to the parabola. So give it some concavities. Okay. It's not just a straight line. Okay. So this is this side here. And for the other side, we have something like this. Okay. So the sketch of the parabola would be something like this. So this is your y equals x squared plus 4x plus 3. Okay? Questions? Okay, so let us now go to our next problem here. Consider the function f of x equals x over x cubed minus x squared minus 4x plus 4. Find the domain of f. Find the value of f of 4. Okay? So for the domain, this is just a rational function. So we just don't want the denominator to be 0. Okay? So for the domain, we find x such that x cubed minus x squared minus 4x plus 4 equals 0. And then once we found this x, we remove them from the set of real numbers. Okay? And that will be the domain of these rational functions. Because you can evaluate these functions, this function at any real number, except for those that will make the denominator 0. So we need to find those x's that will make the denominator 0, then remove it from the set of real numbers. That will be the domain of f. So for this, what we can do is to group these two guys and these two guys in here. We'll have x squared times x minus 1. So for this group, we can factor out x squared. We will be left with x minus 1. For this group, we can factor out negative 4. And we will be left with x minus 1. Okay? So again, for this group, we can factor out x squared. So we will have this x squared. We will be left with x minus 1. For this group, we factor out negative 4. We'll be left with x minus 1 again. So this is equal to 0. Now, we can factor out x minus 1. It's a common factor now. So we will have x minus 1 times x squared minus 4. This is equal to 0. And furthermore, we can factor this. This is difference of two squares. So we will have x minus 1 times x minus 2 times x plus 2 equals 0. This means that our x equals 1, x equals 2, or x equals negative 2. Therefore, the domain of f, this is the set of real numbers except these three guys here. So except negative 2, positive 1, and positive 2. So this is the domain of the function f. Okay? Now, since we've factored this denominator here, which is this guy here, let us rewrite this function as x over x minus 1, x minus 2, x plus 2. So I'm just doing this because it's easier to evaluate the function if it's already in this form. Instead of getting the cube, then getting the square, okay, multiply by negative 4, this guy here. So it will be easier to just plug in the values of x at this form. Okay? And the computation will be reduced. So for number 2, we want to find f of 4. We start with f of 4. So that's just 4 over 4 minus 1 times 4 minus 2 times 4 plus 2. So this is equal to 4 over, you have here 3 times 2 times 6. 3 times 2 times 6. That's just 36. So you have 4 over 36. This is equal to 1 over 9. This is f of 4. Okay? So f of 4, this will be f of 1 over 9. Which means we will have here 1 over 9 divided by 1 over 9 minus 1 times 1 over 9 minus 2 times 1 over 9 plus 2. Okay? So we'll just need to simplify this. Okay? Let us have that. We have in the numerator, that's still 1 over 9. For the denominator, we will have negative 8 over 9. That's for this guy here. And then we have negative 17 over 9. That's for this guy here. And then we will have 19 over 9. That's for this guy here. And therefore, we'll just have to simplify this. Okay? So try to simplify. You will get 81 in the numerator. And then on the denominator, you will just have negative 8 times negative 17 times 19. And that's just 2,584. Okay? And this will be the final answer. Okay? So for our next problem, the height of a triangle is 3 inches more than its base. If the area of the triangle is 35 square inches, find the lengths of the height and the base of the triangle. Okay? So the height of a triangle is 3 inches more than its base. If the area of the triangle is 35 square inches, find the lengths of the height and the base of the triangle. So here, let's introduce our variables. Let h be the height and b be the base of the triangle. Base of the triangle. Then, according to the situation, the height, this is equal to 3 inches more than its base. So base plus 3 inches. Okay? Now, the area is 35 square inches. And the area is, according to the hint here, it's base times height over 2. So now, base times height over 2, this is equal to 35. Or this means that we have base times height, this is equal to 70. So you multiply 2 to both sides of the equation. And now we replace h by b plus 3. So we will have b times b plus 3. This is equal to 70. So let's just solve this equation. On the left-hand side, we will have b squared plus 3b. On the right-hand side, we have 70. Or we can write this as b squared plus 3b minus 70 equals 0. So from here, you can use any method you want. You can use quadratic formula, okay? Or you can use factoring. So I'll be using factoring in here. We can factor this equation into b plus 10 times b minus 7. And this is equal to 0. Okay? But this gives us now b equals -10 or b equals 7. So take note that we are looking for the lengths, okay, of the height and the base. We cannot have negative values. Okay? So it's just b equals 7. So the base is 7 inches and the height, therefore, is 7 plus 3. And the height is 7 plus 3. This is equal to 10 inches. So clearly, this is just what? The area, it's base times height over 2. That's 70 over 2, which is equal to 35 square inches. So this is the final answer. Okay. Questions? Next problem here. A 5-meter ladder leaning on a vertical wall makes an angle of 60 degrees with the ground. Find the exact distance of the foot of the ladder from the wall. Again, a 5-meter ladder leaning on a vertical wall makes an angle of 60 degrees with the ground. Find the exact distance of the foot of the ladder from the wall. So let's say this is the wall, which is a vertical. It's a vertical wall. And suppose this is the ground. And we have a ladder, okay? It's leaning against the wall and it makes an angle of 60 degrees with the ground. So suppose this is the ladder, okay? This is the ladder. This is the 60 degrees. That's the 60-degree angle, okay? It says that the um, the ladder is 5 meters, okay? It says the ladder is 5 meters. So this guy here, this is 5 meters. And we are asked to find the distance of the foot of the ladder from the wall. So from this part here, going to that wall. So we are asked to find the distance here. Let us label that as x. So let x be the distance of the foot of the ladder from the wall of the ladder from the wall. Then how do we find x? We are given the angle 60 degrees and the length of the ladder 5 meters. So if we look at this is just a right triangle. So we can use SOHCAHTOA. We have the adjacent side. Well, we want to find the adjacent side. We have the hypotenuse. So we can use ka in the SOHCAHTOA. Okay? So we have here then cosine of 60 degrees. This is equal to x over 5. Or you have x equals 5 cosine of 60 degrees. And the hint is there. It's cosine 60 degrees, it's 1/2. So this will be equal to 5 over 2 meters. So the distance is 5 over 2 meters. The distance is 5 over 2 meters. Okay? Any questions? Let's move to our next problem here. The revenue, Y, which is in dollars, in selling X units of product is given by a linear function Y equals AX plus B. The revenue in selling 10 units is 1,400, while the revenue in selling 8 units is 1,100. Find the linear function, and then what is the revenue in selling 15 units? Okay? So we have a revenue function. It is represented by Y. We have the number of units of a product, which is represented by X. And it said that the relation between them is the linear function of the form Y equals AX plus B. We are given that the revenue is 1,400 if we have sold 10 units. And the revenue is 1,100 if we have sold 8 units. So find the linear function. Let's do that first. So in here, from this information here, it means that when X equals 10, Y equals 1,400. Okay? So translating this into this equation here, we will have 1,400. This is equal to A times 10 units plus B. Okay? Or let me write it this way. So I'll use the symmetric property. Okay? So I'll be writing it this way. You have A times 10 or 10A plus B. This is equal to 1,400. And then the other information here, when X equals 10 units, revenue is 1,100. So when X equals 8, Y equals 1,100. Which means that we have 8A plus B. This is equal to 1,100. So we have two equations here and two unknowns. The unknowns are A and B. Okay? So we solve this, and then we will be able to get the linear function Y equals AX plus B. So you can solve this using substitution. You can solve this using elimination. Okay? What I'm gonna use is the elimination. So this is equation 1 and the other one is equation 2. So in here, we'll just subtract 1 minus 2. So we subtract equation 1 minus equation 2. So if we do that, we'll have 10A minus 8A. That's just 2A. And then here, B minus B, that's just 0. And then here, 1,400 minus 1,100, that's just 300. Which means that A, this is equal to 300 over 2, which is equal to 150. To solve for B, we just use substitution. Okay? Substituting A equals 150 into, say, equation A or equation number 1. So substituting A equals 150 into equation 1, we'll just have 10 times 150 plus B. This is equal to 1,400. 10 times 150, that's 1,500. So this means we'll just have B equals 1,400 minus 1,500. This is equal to negative 100. So we have a value for A, we have a value for B. We can find the linear function. Therefore, the linear function is y equals 150A minus 100. Sorry, why is that A? 150x. 150x minus 100. Okay? That's just for part 1. For part 2, all we need to do is to substitute x equals 15 units in the equation that we found. Okay? So when x equals 15, y will be equal to 150 times 15 minus 100. So if we do this, we will get 2,250 minus 100. So 2,150. Okay? Which means that the revenue in selling 15 units is $2,150. Okay? Questions? Let's move to our next problem here. Solve for x. We have 3 times x minus 2 minus 5x equals 2 times 4x plus 1 plus 6. So this is just a linear equation, so we can just isolate the x on one side of the equation and then the constant on the other side of the equation. So we have here 3x minus 6 minus 5x. This is equal to 8x plus 2 plus 6. Okay? And then we move this to the left-hand side. We move this to the right-hand side there. So we will have 3x minus 5x minus 8x. This is equal to 2 plus 6 plus 6. So on the left-hand side, we will have minus 10x On the right-hand side, we will have 14, which means that our x, this is negative 14 over 10, or this is equal to negative 7 over 5. Okay? So this is the solution to the linear equation. Okay? Next, solve for P in the formula A equals P plus PRT. So in here, all we need to do is to isolate P because we just want to solve for P. Okay? So to do this, look at this part here. We have a P. We also have a P on this part. So P is a common factor. So this guy here, we can rewrite as P times 1 plus RT. And therefore, to solve for P, all we need to do is to divide by 1 plus RT. So we will have P equals A over 1 plus RT. So this is the formula for P. Okay? From the original formula, A equals P plus PRT. Questions? Next problem. Solve for the variable using factoring. So in here we have the equation t cubed minus 9t squared equals 22t. So in here we are specifically asked to use factoring. So I hope you've been practicing your factoring. So first, let us put everything on one side of the equation. And then on the other side, we just have 0. So this guy, we will have t cubed minus 9t squared minus 22t. This is equal to 0. And then we factor t because it's a common factor. We have t cubed here, t squared here, and then t here. So we can easily factor t. And what remains inside is the expression t squared minus 9t minus 22. This is equal to 0. Okay? And you can factor this. Just use your method. Okay? So for the solution that I will show you here, we'll do the complete details. So remember, we have your A here, that's equal to 1. Your B, that's equal to negative 9. Your C, that's equal to negative 22. So we don't actually need to write A in here. But anyway, so we want to find A and B such that the product AB, that's equal to C, and the sum A plus B, that's equal to B. So you again write your table. We have capital C, small a, small b, capital B. That's right. Small a plus small b, this is equal to capital B. Capital C, that's negative 22. So there are only few choices. So let's use the correct pair here. We will have negative 11 and positive 2. Okay, So negative 11 times positive 2, that's negative 22. And if you add them, you will get negative 9, which is the B that we need. Therefore, we will now have t times t minus 11 times t plus 2. This is equal to 0, which means that we will have t equals 0, t minus 11 equals 0, t plus 2 equals 0. Of course, we just have t equals 0 in here. From this guy here, we'll get t equals 11. And then from this guy here, we'll get t equals negative 2. So these are the solutions to the equation t cubed minus 90 squared minus 22 equals 22t. Okay? So again, just a reminder, you were asked to use factoring. If you solved this by other means, you might not get any points. Okay? Next problem, solve for x in the equation x over 4 minus x minus 3 over x plus 4 equals 5 over x squared minus 16. So in here, let us just write the restrictions. We don't want 4 minus x to be 0. We also don't want x plus 4 to be 0. And x squared minus 16 to be 0. So we don't want these three cases. Here, it means x equals 4. Here, it means x equals negative 4. Here, remember that x squared minus 16, you can factor that into x minus 4, x plus 4. Okay? X minus 4, x plus 4. So this means that you'll have x equals 4 or x equals negative 4. So we don't want these cases. So we don't want this, which means that that the x should not be equal to 4 and negative 4. Okay? So you can do any method you want. Okay? You can use LCD method. You can combine them into a single fraction. Okay? Say let's combine these two guys here into a single fraction. Okay? Then on the left hand side, we will have in here, you will get what? This means you will have 4 minus x times x plus 4. And therefore, for this guy, we'll just have x times x plus 4. Then minus 3 times, for this guy, we have minus 3. We multiply it by 4 minus x. On the right hand side, we can just copy it, 5 over x squared minus 16. And then let us simplify the numerator. The numerator, you will have x squared plus 4x minus 3 times 4, that's 12, or that's minus 12. And then we have minus 3 times minus x, that's plus 3x. On the denominator, if you get this guy here, what you will get is 16 minus x squared. The other side here, we will have 5 over x squared minus 16. Okay? So the denominators, they are almost the same, except that one is a negative of the other. This is 16 minus x squared. This is x squared minus 16. So we can take out the negative in here. And then at the same time, let us simplify the numerator here. So the numerator, it will just be x squared plus 7x minus 12. The denominator, let us take out negative, and we will have here x squared minus 16. And then on the other side, we'll just have 5 over x squared minus 16. And then we can bring this negative here on the numerator. So if we do that, we'll just get minus x squared minus 7x plus 12. On the denominator, you'll just have x squared minus 16. On the other side, we'll have 5 over x squared minus 16. Now you have the same denominators. All you need to do here is to equate the numerators. So this means that you will have negative x squared minus 7x plus 12. This is equal to 5. Okay? And then let's just write this in standard form. We will have x squared plus 7x minus 12 plus 5 equals 0. So what happened here? These three guys, I put it on the other side. So you will have this 5. Then this guy will go to that side. So it becomes plus x squared. This guy, put it on that side. That becomes plus 7x. This guy, we put it on the other side. That becomes minus. And then I use symmetric property. Okay? That's why we have this equation here. And then from here, simplifying further, we will have, let me write it on this part. We will have here x squared plus 7x, then minus 12 plus 5, that's minus 7, equals 0. Okay? And then, lastly, we can find the value of x. Let's use quadratic formula. So x equals negative 7 plus or minus square root of 7 squared minus 4 times 1 times negative 7 all over 2 times 1. So in here we have minus 7 plus or minus square root of 49 plus in here you have 28. Then all over 2. So this is negative 7 plus or minus. And then in here, we'll have square root of 77 over 2. So this is, or these are the values for x. Okay? Questions? Next problem. We have to solve for x in the equation square root of 8x plus 33 minus 3 equals 2 times square root of 2x. So in here, in this particular form, okay, this radical here is already isolated on one side of the equation. So we can start our solution by squaring both sides of the equation. So if we do this, on the left-hand side, we will have square root of 8x plus 33 squared. So that's just 8x plus 33 minus twice the product, minus because this is minus, and then twice the product of this and this. So that will become minus 6 times square root of 8x plus 33. And then plus the square of this, and that's just plus 9. On the other side, we'll just have 4, that's 2 squared, times square root of 2x squared. So 4 times 2x in here. So from here, we'll just have 8x plus 33 plus 9, that's 42, minus 6 square root of 8x plus 33. This is equal to 4 times 2x, that's just 8x. So notice that this guy here can cancel this guy. They are on the opposite sides of the equation and they are exactly the same. So they can cancel each other. So we will end up with, and then we put this side, or we put this on the other side of the equation, or maybe this guy here on the other side of the equation. So in any case, you will end up with negative 6 square root of 8x plus 33. This is equal to negative 42. And then from here, we can divide by 6, by negative 6. Negative 42 is divisible by negative 6. So we'll just have 8x plus 33 on the left-hand side. On the right-hand side, we'll just have 7. Okay? And then what? We square both sides. On the left-hand side, we'll just have 8x plus 33. On the right-hand side, you get 49. And then we solve for x. So we have 8x equals 49 minus 33. 49 minus 33, this is just 16. Therefore, x is equal to 2. Okay? Now we check if x equals 2 satisfies the original equation here, without the squares, of course. Okay? If x equals 2, then we have square root of 8 times 2 plus 33 minus 3. Is this equal to 2 times square root of 2 times 2? But in here, we have square root of 8 times 2, that's 16 plus 33, minus 3. On the other side, we have 2 times 2, that's just equal to 4. So inside there, it's 2 times 2, that's 4. You take the square root, that's 2. Okay? So this guy here, it's 4. You take the square root, that's 2. You multiply it by 2, we get this 4. Now for this side here, 16 plus 33, that's actually 49. So we will have square root of 49 minus 3. Is this equal to 4? Indeed. Square root of 49, that's 7. So 7 minus 3, this is equal to 4. So we can conclude that this is our solution. Okay? Questions? Next problem, we solve for x in the equation 3 raised to 2x minus 5 equals 1 half. Okay? So in here, well, they don't have the same base, and we cannot write one base in terms of the power of the other base. So we'll use logarithms. We use base 3 in the logarithms. Okay? So for this, we want log base 3 of 3 raised to 2x minus 5. This is equal to log base 3 of 1 half. Okay? And then, what does this mean? On the left-hand side, it only becomes 2x minus 5. Okay? On the other side, we can write this as, well, negative log base 3 of 2. Okay? But anyway, you can write log 1 half of log of 1 half base 3. So anyway, how is this? This guy here, this is just log base 3 of 1 minus log base 3 of 2. And this guy here, this is 0. Okay? So from here, we just need to solve for x. We have 2x equals 5 minus log base 3 of 2. And therefore, x, this is just 5 minus log of 2 base 3 all over 2. So this is the solution to the equation. Okay? Questions? Next problem, find the solution set. 3 times x minus 5 minus 5x plus 7 greater than or equal to x minus 4. So first, let us just expand this. We multiply this over this x minus 5, and then we simplify. So we will have 3x minus 15 minus 5x plus 7 greater than or equal to x minus 4. And then we put the variable x, or all terms with variable x, on the left-hand side of your inequality. Then the constants on the other side of the inequality. Let us simplify first the left-hand side. This is just minus 2x, and then minus 8. So greater than or equal to x minus 4. Now we move this on that side. We move this on this side. And therefore, we will have minus 2x minus x greater than or equal to minus 4 plus 8. Or here we will have minus 3x greater than or equal to 4. Now we divide by negative 3. And once we do the division, this inequality will be reversed. So we will have x less than or equal to negative 4 over 3. So these are the values for x that will satisfy the inequality. For the solution set, we can use interval notation. So this is just from negative infinity up to negative 4 over 3, and then close bracket here. Okay? Any questions? Next problem here. Let A be the point negative 1 comma 3, B be the point 4 comma 2, and C be the point 1 comma negative 2. So 3 problems. Determine the distance between A and B. Determine the midpoint of the line segment whose endpoints are B and C. And then consider the line segment whose endpoints are A and a point X with coordinate X comma Y. If C is the midpoint of this line segment, find the point A. So let's start with 1. We want to find the distance between A and B, but this will be easy. We use the distance formula, so this is just a square root. So A and B in here, we have 4 minus negative 1 quantity squared plus 2 minus 3 quantity squared. So 4 minus negative 1 quantity squared, then 2 minus 3 quantity squared. So for this, we'll just have square root of 4 minus negative 1, that's 5 squared, plus 2 minus 3, that's negative 1 squared. So this is just a square root of 25 plus 1, which is equal to square root of 26. So this is the distance between A and B. Okay? For number 2, we want to find the midpoint between the midpoint of the line segment with endpoints BC. So for this, the midpoint, all we need to do is to, again, use our formula. X coordinates, you add them, divided by 2. The y coordinates, you add them, divided by 2. So for the x coordinates, you have 4 plus 1 divided by 2, comma. For the y coordinates, you have 2 minus 2 divided by 2. So this is just 5 over 2, comma, 0. So this is the midpoint between B and C, or the midpoint of the line segment with endpoints B and C. Okay? For number 3, so we consider the line segment whose endpoints are A and X. Okay? And then we find the coordinates of X if C is the midpoint of that line segment. So again, midpoint AX, this will just be negative 1 plus X over 2, comma, 3 plus Y over 2. This should be equal to C because C is the midpoint. So in here, we are using the formula for the midpoint, but the midpoint is known, it's the point C, and it's just 1, comma, negative 2. So what does this mean? You have negative 1 plus X over 2. This must be equal to 1. And 3 plus Y over 2. This must be equal to negative 2. Or in here, we have negative 1 plus X. That should be equal to 2. 3 plus Y. This should be equal to negative 4. Which means that in here, we will have X equals 2 plus 1, which is equal to 3. So this is our X. And then here you have Y equals minus 4 minus 3. This is equal to minus 7. Okay? Therefore, let me just insert it here. So the point X has coordinates 3, comma, negative 7. Okay? Questions? Next problem. Let L be the line given by the equation 3x plus 8y equals 5. Give the slope of L. That's your first problem. Second, give the equation of the line in slope-intercept form that is parallel to L and contains the point negative 2, comma 1. Then third, give the equation of the line in a slope-intercept form that is perpendicular to L and contains the point negative 2, comma 1. So first, let's find the slope of L. So from the equation 3x plus 8y equals 5, we can isolate y. So we will have 8y equals minus 3x plus 5, which means that y, this is equal to negative 3 over 8x plus 5 over 8. Therefore, slope of L, this is equal to negative 3 over 8. For number 2, give the equation of the line in slope-intercept form that's parallel to L and contains the point -2, 1. So in here, the desired line has equation y equals -3/8x plus b. It's parallel to L. To solve for b, we use this point here. Okay? So we will have -2. This is, sorry, it's +1. This is equal to -3/8 times -2 plus b. Okay? Or this is, so -3 times -2, that's 6/8. 6/8, that's 3/4. So this is 3/4 plus b, which means that b, this is equal to 1 minus 3/4, and this is equal to 1/4. Okay? So the line has equation. This is given by y equals -3/8x plus 1/4. So this is the desired line. Okay? For number 3, we need the perpendicular. Okay? So we need the slope that is perpendicular to L. So this is just -1 over slope of L, and we've calculated that to be -3/8. So this is simplified into 8/3. So the desired line has equation we have y equals 8/3x plus b. And again, to solve for b, we use the point -2, 1. So we will have 1. This is equal to 8/3 times -2 plus b. But this will just be -16/3 plus b. Which means that our b, this is just 1 plus 16/3, and this is equal to 19/3. Therefore, the line is, so thus the line is y equals 8/3x plus 19/3. So we have this equation. Okay?
Can you go back a little, please? Like for 2 seconds.
This guy here.
On this. Thank you.
Okay. So let us now go to our next problem here.
No, break.
So we consider the graph of the quadratic function f of x equals x squared plus 2x minus 3. Then we have this series of um, problems here. Find the y-intercept, find the x-intercept, give the vertex of the graph of y equals f of x, give the equation of the axis of symmetry of y equals f of x, and then sketch the graph. Label the important points or parts. It means that you have to label the vertex, the intercepts, the axis of symmetry. And then there's an additional question here. Locate on the graph the point where x equals negative 4. So we will all do this. For number 1, y-intercept, okay, we let x equal 0, then y is just equal to negative 3. Okay, so y-intercept, it's negative 3. Okay, so we have the first. For the second, we want to find the x-intercept, so we let y be equal to 0. Then we have x squared plus 2x minus 3. This is equal to 0. We can factor this. You can solve for the values of x. We can factor this. Okay. We'll have x plus 3 times x minus 1. This is equal to 0, which means you will have x equals, or x plus 3 equals 0, or x minus 1 equals 0, or that we have x equals negative 3, or x equals 1. So the x-intercepts are negative 3 and positive 1. Okay? Let's find the vertex. So for number 3, the vertex, it's just hk. H here, it's negative b over 2a. So for this, your a, it's there. This is your b. And later, maybe we'll use it. This is your c. And then in here, negative b over 2a, it means we will have negative 2 over 2 times 1. This is just negative 1. K, this is f of negative 1, which means we'll just have negative 1 squared plus 2 times negative 1 minus 3. This is 1 minus 2 minus 3. This is equal to minus 4. Therefore, the vertex is at the point negative 1 comma negative 4. And then for the axis of symmetry, this is just the line x equals h. So this is just x equals negative 1. Okay? And then we are asked, for number 5, we are asked to sketch the graph, but we will also need to locate on the graph the point where x equals negative 4. So let us do that. Okay. f of negative 4, this is equal to negative 4 squared plus 2 times negative 4 minus 3. So this is equal to 16 minus 8 minus 3. This is equal to 5. So we have the point, okay? So we need, or we have the point negative 4 comma 5. Okay? So now we are ready to sketch the graph. So on this grid, let me just label the ticks here one by one. 1:1, the scale. So this is 1. So let me use black here. 1, 2, 3, 4. Here we have negative 1, negative 2, negative 3, negative 4. Maybe I'll put negative 5 in here. For the y-axis, we have negative 1, negative 2, negative 3, negative 4, negative 5. And then up here, we have positive 1, positive 2, 3, 4, 5. Let's put 6 in here. Let's start with the vertex. The vertex is at negative 1, comma negative 4. So negative 1, comma negative 4, it's on this part. This is the vertex V. Negative 1, comma negative 4. And then the axis of symmetry, it's the line x equals negative 1. So the line x equals negative 1. So let's just use this guy here. Okay. So this is the line x equals negative 1. Let me use red part, red ink there. So we have the vertices. We have the vertex. We have the axis of symmetry. Let's get this point here, negative 4, comma 5, since we will have to locate that also. So negative 4, comma 5, it will be at this point here. Okay, so this is negative 4, comma 5. Okay, we use the intercepts to get other points. So when x equals 0, y equals negative 3. Okay, so when x equals 0, y equals negative 3. So we have the point 0, comma negative 3. So it's this point here. So 0, comma negative 3. And then when y equals 0, x equals negative 3, and positive 1. So we have the point negative 3, comma 0, 1, comma 0. So negative 3, comma 0, it's this point here. And then 1, comma 0, it's this point. So for here, we have 1, comma 0. And for here, we have negative 3, comma 0. Okay? And now, we can sketch the graph of the parabola. So it will be something like this. Okay? So again, give justice to the parabola. Okay? It's not just straight line. Okay? So that's the left side. For the right side, we have something like this. Okay. So this is the sketch of y equals x squared uh, plus 2x minus 3 plus 2x minus 3. Okay. Questions? Next problem here. A small company determined that the revenue from selling X units of a certain product is given by the function r of x equals negative 0.02 x squared plus 8x. Determine the number of units that must be sold to get the maximum revenue. What is the maximum revenue? So look at this. You have a quadratic function in here. Okay. The coefficient of x squared, it's a negative number. So the graph of this quadratic function, it's a parabola which opens downwards. And if the parabola opens downwards, it has a maximum point. The vertex is the maximum point. The coordinates of the vertex will answer these two problems. So the x-coordinate, it's the number of units that must be solved to get the maximum revenue. And then the y-coordinate, it's the maximum revenue. Okay? So in here, okay, let's just write this. The vertex of the graph of r of x, or y equals r of x, let's write that information. Y equals r of x, okay, is the maximum point. Is the maximum point. Maximum point. Okay. The x-coordinate, the x-coordinate of the vertex, coordinate of the vertex answers 1. The y-coordinate, the y-coordinates answers 2. Okay. So let's see. So we have the vertex h comma k. We have h that's equal to negative 2, negative b over 2a. Negative b, that's negative 8. And then 2a, that's 2 times negative 0.02. So this is just 8 over 0.04. So this will be 800 over 4, or this is equal to 200. Okay? K, this is just R of 200. Okay? But R of 200, this is just negative 0.02 times 200 squared plus 8 times 200. So in here, let us just calculate this. 200 squared times 0.02. So we will have minus 800 plus 1,600. This is equal to 800. So what does this mean? Therefore, the company must sell 200 units, okay, to get the maximum revenue, which is $800, which is $800. So this is the answer to this problem. Okay. So if 60 coins consists of tunis, there are $2. They are two Canadian dollars, and loonies, which are one Canadian dollars. How much of each are there if they are $82 in total? So if 60 coins consist of tunis and loonies, how many of each are there if they are $82 in total? So here, let X be the number of tunis, Y be the number of loonies. Okay. Then, according to the problem, there are 60 coins. We have X plus Y. This must be equal to 60. Furthermore, total is $82. So X number of tunis. So 2 times X plus Y, the number of loonies. So plus Y. So 2 times X, that's the total amount for the tunis. Y times $1, that's the total amount for loonies. So if you add these two guys here, we should get $82 in total. So we can solve for X here or Y here. We can solve for both of them. This is just a system. So you can use substitution, you can use elimination method. So for this, I'll use elimination method. I can easily eliminate variable y. So in here, what I'm going to do is to subtract equation 2 minus equation 1. So the operation is going up. So we have 2x minus x. That's just your x. And then y minus y, that's 0. And then we have 82 minus 60. That's just 22. So there will be 22 tunis. And therefore, we will have y. We can use equation 1 or equation 2 to solve for y. Let us use equation 1. So we will have y equals 60 minus 22. This is equal to 38. Okay? Therefore, there are 22 tunis and 38 dunis.